This is day 15 of Advent of Cyber 2024, and this challenge is called Be It Ever So Heinous, There's No Place Like Domain Controller. Ahead of Sockmas, the team decided to do a routine security check of one of their Active Directory domain controllers. Upon some quick auditing, the team noticed something was off. Could it be? The domain controller has been breached. With sweat on their brows, the SOC team smashed the glass and hit the panic alarm. There's only one person who can save us. So the learning objectives are to learn about the structures of Active Directory, learn about the common Active Directory attacks, and investigate a breach against an Active Directory. So to start this, we just need to start the machine like so, and it will open up in split view here, but if you are connected to the VPN, you could RDP into it if you wanted to. Introduction to Active Directory. Before diving into Active Directory, let us understand how network infrastructures can be mapped out and ensure that access to resources is well managed. This is typically done through directory services, which map and provide access to network resources within an organization. The Lightweight Directory Access Protocol, LDAP, forms the core of directory services. It provides a mechanism for accessing and managing directory data to ensure that searching for and retrieving information about subjects and objects such as users, computers, and groups is quick. Active Directory, AD, is, therefore, a directory service at the heart of most enterprise networks that stores information about objects in a network. The associated objects include users, individual accounts or representing people or services, groups, collections of users or other objects, often with specific permissions, computers, machines that belong to the domain governed by AD policies, printers and other resources, network accessible devices or services. The building blocks of an AD architecture include domains, logical groupings of network resources such as users, computers, and services. They serve as the main boundary for AD administration and can be identified by their domain component and domain controller name. Everything inside a domain is subject to the same security policies and permissions. Organizational units. OUs are containers within a domain that help group objects based on departments, locations, or functions for easier management. Administrators can apply group policy settings to specific OUs, allowing more granular control of security settings or access permissions. Forest. A collection of one or more domains that share a standard schema, configuration, and global catalog. The forest is the top-level container in AD. Trust relationships. Domains within a forest and across forests can establish trust relationships that allow users in one domain to access resources in another, subject to permission. Combining all these components allows us to establish the distinguished name that an object belongs to within the AD. The structure of the name would be as follows. So you have distinguished name, then you've got the CN for malware, OU management, DC Wervel, and DC THM. Core Active Directory components. Active Directory contains several key components that allow it to provide a wide range of services. Understanding these components will give one a clear picture of how AD supports administrative security operations. Domain controllers, DCs, are the servers that host Active Directory services. They store the AD database and handle authentication and authorization requests, such as logging in users or verifying access to the resources. Multiple DCs can exist within a domain for redundancy. When changes are made to AD, such as adding users or updating passwords, these changes are replicated across all DCs, ensuring that the directory remains consistent. Global Catalog. The Global Catalog, GC, is a searchable database within AD that contains a subset of information from all objects in the directory. This allows users and services to locate objects in any domain in the forest, even if those objects reside in different domains. LDAP. AD uses the protocol to query and modify the directory. The protocol allows for fast searching and retrieval of information about the objects, such as users, computers, and groups. Kerberos Authentication. The default authentication protocol used by AD provides secure authentication by using tickets rather than passwords. Group Policy. One of Active Directory's most powerful features is Group Policy, which allows administrators to enforce policies across the domain. Group policies can be applied to users and computers to enforce password policies, software deployment, file settings, and more. Group Policy Objects. GPUs are the containers that hold these policies. A GPU can be linked to the entire domain, an OU, or a site, giving the flexibility in applying policies. So let us say that McCity wants to ensure that all users within Wervel SOC follow a strict password policy, enforcing minimum password lengths and complexity rules. Here's how it would be done. So what we need to do is using the run window, which is, so I think we need to go run. So go to run, then we go gpmc.msc. So we right click, so we need to drop down here, go to, I think it domains here in this one, create GPO in this domain and link it here. So we'll name it password policy, and then we need to see, assume it's here, password policy. So forest, domains, wervel.thm, group policy objects, password policy. Okay, so we now need to edit the GPO. So right click and then go edit, and computer configuration, policies, window settings, security settings, account policies, and then password. So on this GPO we need to define minimum password length, I selected the wrong one, password age, minimum password length, and we'll make that 12. Password history, change that to 10. So remembers your past 10 passwords so you can't reuse it. Maximum password age, we will define that and change it to 90. Then we click, apparently says OK, but I can't see where. I think we've got that done. Well, let's continue. Common Active Directory attacks. Adversaries are always looking for ways to breach and exploit Active Directory environments to destabilize and cause havoc to organizations. Working with Glitch to secure SOCMIS requires us to know common attacks and their mitigation measures. Golden Ticket Attack. A golden ticket attack allows attackers to exploit the Kerberos protocol and impersonate any account on the AD by forging a ticket granting ticket. By compromising the KRBTGT account and using its password hash, the attackers gain complete control over the domain for as long as the forged ticket remains valid. The attack requires 4 critical pieces of information to be successful: the fully qualified domain name, the SID of the domain, username of an account to impersonate, and the KRBTGT account password hash. Detections for this attack involves monitoring for unusual activity involving it. So vendor ID 4768, and then vendor ID 4672. Pass the hash. This type of attack steals the hash of a password and can be used to authenticate to services without needing the actual password. This is possible because the NTLM protocol allows authentication based on password hashes. Key ways to mitigate this attack are enforcing strong password policies, conducting regular audits on account privileges, and implementing multiple factor authentication across the domain. Kerberoasting is an attack targeting Kerberos in which the attacker requests server keys for accounts with service principal names, extracts the tickets and password hashes, and then attempts to crack them offline to retrieve the plaintext password. Mitigation for this type of attack involves ensuring that service accounts are secured with strong passwords, and therefore implementing secure policies across the AD would be the defense. Pass the ticket. In a pass the ticket attack, attackers steal Kerberos tickets from a compromised machine and use them to authenticate as the user or service whose ticket was stolen. This attack can be detected through monitoring for suspicious logins using event 4768, and additionally 4624 will reveal tickets being used for authentication. Malicious GPOs. Adversaries are known to abuse group policy to create persistent privileged access accounts and distribute and execute malware by setting up policies that mimic software deployment across entire domains. With escalated privileges across the domain, attackers can create GPOs to accomplish goals at scale, including disabling core security software and features such as firewalls, antivirus, security updates, and logging. Additionally, scheduled tasks can be created to execute malicious scripts or exfiltrated data from affected devices across the domain. To mitigate against the exploitation of group policy, GPOs need to be regularly audited for unauthorized changes. Strict permissions and procedures for GPO modifications should also be enforced. Skeleton key. In a skeleton key attack, attackers install a malware backdoor to log into any account using a master password. The legitimate password for each account would remain unchanged, but attackers can bypass it using the skeleton key password. So, investigating an Active Directory breach. Group policy. As previously discussed in this task, group policy is a means to distribute configurations and policies to enroll devices in the domain. For attackers, group policy is a lucrative means of spreading malicious scripts to multiple devices. Reviewing group policy objects is a great investigation step. In this section, we'll use PowerShell to audit our GPUs. First, we can use the get GPUs command to list all GPUs installed on the domain controller. So if we open up PowerShell and let's run it as administrator, we can do get-gpu space dash all. So this would allow us to look for out-of-place GPUs. We can export a GPU to an HTML file for further investigation to make it easier to see what configurations the policy enforces. For this example, we will export the set wallpaper GPU. So we'll do that, do dash name set wallpaper, and the report type is HTML, and the path we will sending it to is set wallpaper.html. Okay, well apparently I entered it wrong, so let's just copy and paste it in. There's no way to paste it in. Okay, well, let's try again. So that does look correct. Dash report type HTML. Oh, I forgot, I didn't change the beginning, so get dash GPU report. Set wallpaper GPU was not found. Alright, so we're not meant to be following along with this apparently, because they've got that there and then we don't. Okay, well I guess we can just ignore everything they've written. When opening the HTML file in the browser, we are presented with an overview of things such as when the policy was created and modified, what devices or users the GPO applies to, the permissions over the GPO, the user or computer configurations that it enforces. From the screenshot above, we can see that the policy sets the desktop wallpaper of devices using the image located in cthm.jpg on the domain controller. Domains are naturally likely to have many GPOs. We can use the same get GPO commandlet with a bit of PowerShell foo to list only those GPOs that were recently modified. This is a handy snippet because it highlights policies that were recently modified, perhaps by an attacker. Event Viewer. Windows comes packaged with the Event Viewer. This invaluable repository stores a record of system activity, including security events, service behaviors, and so forth. For example, with the Security tab of Event Viewer, you can see the history of used logins, attempts, and logoffs. The screenshot below shows a record of the user CMNatic attempting to log into the device. All categories of events are given an event ID. The table below provides notable event IDs for today's task: 4624 for log on, 4625 failed to log in, 4672 special privileges has been assigned, 47G8 ticket granting ticket was requested for hybrid ledger account. User auditing. User accounts are a valuable and often successful method of attack. You can use event viewer IDs to review user events and PowerShell to audit their status. Attack methods such as password sparing will eventually result in user accounts being logged out, depending on the domain controller's lockout policy. To view all locked out accounts, you can use the search AD account commandlet, applying some filters to show information such as the last time the user had successfully logged in. Additionally, a great way to quickly review the user accounts present on a domain, as well as their group membership, is by using the get-aduser commandlet demonstrated below. Reviewing PowerShell history and logs. PowerShell, like Bash on Linux, keeps a history of the commands inputted into the session. Reviewing these can be a fantastic way to see recent actions taken by the user account on the machine. On a Windows server, this file is located in AppData, Microsoft Windows PowerShell, PS Readline, console host history. You can then use the built-in notepad tool to read it. Additionally, logs are recorded for every PowerShell process executed on a system. These logs are located within the Event Viewer under Applications as Service Logs, Microsoft Windows PowerShell is operational, or also under Application Service Logs, Windows PowerShell. The logs have a wealth of information useful for incident response. So practical. Task today is to investigate Wearable SOCMIS Active Directory controller for the suspected breach. Answer the questions below to confirm the details. So we need to go to Event Viewer. We need Security tab. What's the Security tab? So it's okay. So Windows Logs Security. That's what they mean. So we are there. What day was glitch malware last logged in? So we need to find event ID 4624. Then we would need to filter current. I assume it's that. And event ID this. Oh, right, you can't copy and paste. So 4624. And can we filter on values? User do glitch malware. Okay, apparently not that. Maybe let's remove this. Nope, that didn't help. So let's just go 4624 and we will remove the user. So let's take a look at the logs. That is a lot of logs here. Okay, so let's try this date, because this is the first one we see that's not 1120. Okay, let's try, let's take a look at this. It's not saying any users for these. Can we do find like this? Oh, we did. Although let's go to the top first and do that again. It's a glitch malware. Okay, so it's 11/7/2024. No? Isn't that a user has logged on? Okay, maybe we need to clear the filter. Go back here and then do glitch malware. Oh, so it's asking for this format. So that would be 07/11/24. There we go. Event ID shows the login, 4624. So read the PowerShell history of the admin account. Why is it shutting down? Well, that's great, isn't it? Okay, well, not sure why the virtual machine shut down. Had to restart it, so now we're back here. We need to search for the admin's, what do you call it? PowerShell history. Let's go to this PC. So users, go to administrator, and we need to view hidden. Go to app data, and where was it? So app data, I think local, Microsoft, Windows, PowerShell, and apparently it's not local. Go roaming maybe. Microsoft, Windows, PowerShell, there you go, PS3 line, and console history. So it's asking for this one here. Can we copy that into here? Yes, we can. So look in the PowerShell log file in Application Services, Windows PowerShell. So I guess I assume that we're talking about Event Viewer. So open that back up, and Application Service Logs. Is it loading or? Okay, there we go. Windows PowerShell, and set password. Can we do just a Control F in here and do password? Did they talk about password in here? Did they give the event ID for password here? Okay, they didn't. So how do we find the password? Do I need to search for him again? Just like that? Oh, right, you can't copy and paste. Is it this one we want? Okay, well that's not doing anything, so maybe filter, user, glitch, malware. There's no events for them. Okay, maybe we need to look it up. Event viewer, event ID password change, 4724. Did they mention 4724 here? I thought they did, but I didn't see it. 4724. Okay, no they didn't. 4724. Oh, okay. I'm not pressing that. 4724. Okay, what's the hint? Use the find option to search for the password. I mean, it's not even showing the PowerShell logs anymore. So I guess I need to restart this machine again or something because there's no logs. Okay, now they're there. Okay, so it said to search for password. Okay, there's nothing there, so I need to restart this machine again. I brought up the virtual machine and it's now just stuck like this. So I guess I gotta try restart it and wait another 10 minutes. I restarted it again and it's just not working. So I'm not going to waste any more time on this. I'm just going to go through this video and find the answer. Okay, so in that video we can see the password was changed to, what was it, super secret word, something like that. Yep. And then the group policy object is malicious GPO dash glitch underscore malware persistence. So glitch underscore malware persistence. And that is all the questions answered. I don't know what it is with these Windows machines, but I just seem to have problems with them all the time. So track me need to get that sorted out. But anyway, if you like this video, make sure to like and subscribe.